Good morning, students. Welcome back to science class on the chapter electricity. In the previous class, we had discussed the problem range. So today also we discuss some problems. Okay. So first I'll write the problem. Yes. So here, find the current drawn by the battery and the potential difference between A and B. Okay. See here these two resistors are in parallel and this one is in resistance. See this resistor is series with this combination. Okay. So now here find the potential difference between A and B. Okay. Yes. Find out. I give 2 minutes time. So find the potential difference between A and B. See here voltage here and here same. Why? Because these two are parallel, but voltage here and across this combination that is different. Yes, overall minimum current I is equals to 0.5 A. Okay. (0.6 ampere). Okay. So first solve these two resistors. Okay, so here this is R1, R2, R3. Okay, so first 1 by RP, 1 by RP is equals to 1 by R2 plus 1 by R3. So 1 by 5 plus 1 by 10. So LCM of 5 and 10 is, that is 10. Okay, so here you have to multiply 2 and here 1. So 2 plus 1. So 1 by RP, we need RP. So RP is equal to, we can write 10 divided by 3. So what is the answer? 10 divided by 3, that is 3.33. Okay, 3.33 ohm. 3.33 ohm. So now we can redraw this circuit as, this circuit as like this. Okay, A and B, RP is equals to 3.33 ohm. Okay, yes. So here we need voltage across here. I will call voltage across here as V1 and V2. See, we don't want V2, just we need V1. So voltage across A and B. We need voltage across A and B. So RP is 3.33. Okay. So here to calculate V1, we know the formula, that is V1 is equals to I into R1. Here we know the, see, V1 means here RP, right? Here we need voltage across this resistor. So here we have to use the value of this resistor. So that's why V1 equal to V into RP. Clear? We need voltage across this resistor. Okay? Yes. Now V1 equal to RP. So we know the value of RP and we know the value, but we need V1, right? If you want to calculate V1, then you should know I and RP. We know the value of RP, but we don't know I value. Okay? First find out I value. You know, right now these two resistors are in series. So here current across R1 across RP current remains same. Okay? Yes. If you want to calculate current, then we know the formula, that is V is equals to I into R. Clear? Here we know the V value, that is 5 voltage. Okay? But we don't know R value, right? Yes. Find out R value. Now these two, solve these two resistors. Quick. Kirtan Joshi, R is equals to 3.33 ohm. Yes, correct. So solve here. RS is equals to R1 plus RP. RS is equals to R1 plus RP. So now I am solving these two resistors. Okay. So this is 5 and this is 8.33. So 3.33. Okay. So if you add these two, you will get 8.33 ohm. So RS. Okay. And here I'll write this RT value. So RT is equals to 3.33 ohm. RP is equals to 3.33 ohm. Okay. Yes. Here we got the total resistance of the system, that is RS equal to 8.3. Now you can redraw this circuit as, don't need to take RS, just write R. Okay. Yes. So we can redraw that circuit as, so R is equals to 8.33 ohm. Okay, now find out current. We need I, right? So V by R equal to I. We can write I is equals to V by R. So V value is 5 divided by 8.33. Okay. So better here into 100 and divided by 100. That is I is equals to 500 divided by 833. So tell me what is the answer? I is equals to 0. Okay, when you are find it later, you will get 0.6 ampere. 0.6 ampere. Okay, so now we got a current, right? Yes. So now substitute here. So V1 is equals to 0.6 into RP value, that is 3.33. Yes. Now multiply these two. Here you get the answer. V1. V1 means what? Voltage between point A and B. See, actually this is the diagram, right? See, this was the actual diagram. Okay, this is point A and point B. 5 ohm and this is 10 ohm. Actually, we need voltage between A and B. If you want to calculate the voltage between A and B, first we solved these two resistors. We got that is 3.33. Okay, 3.33. 3.33 ohm. So now we can calculate voltage across A and B. That is, so multiply here 0.6 into 3.33. So you will get so here you will get 1.98, so which is approximately equal to 2 voltage. Okay, because here we will get 3.3333, right? So that's why we will get 1.9. So it is approximately equal to 2 voltage. So so many students answered here. So we equal to 1.998, correct? Exact, right? Kiran Joshi 4.99, it's wrong. Tanuja Guttedwar, you answer correct, 1.9, correct. Sampath Kumar 0.67, that is also correct. Sampath V equal to 1.91. Yes, correct. Okay. Yes, next one. Find Yes, here find the total resistance and the total current drawn from the battery. Here we need total resistance and total current. Okay, so here these two resistors are in series, these two resistors are in series, this combination, both are in parallel. Okay. Yes, find the answer for this question quick. Total resistance of circuit. Okay, so first of solve these two and these two, then these two become one, these two become one, so finally get both are parallel to each other. Okay, quick. Yes sir, I'm waiting for your answer. Sampath Kumar, first 0.6 ohm. No, it is impossible. See here, these two are connected in series. So here you should get the resistance greater than this one and this one. Yes, R is equals to, see now take this one as R dash and this as R double dash. Okay, R dash, because here you can't take right 2 times RS. So first R equal to 7.5 ohm, is it right? No. So take this one as RS1, RS2 or R1. You can take any name, okay? But don't take same. Yes, first one, see here, RS1. RS1 is equals to R1 plus R2. See here, just we are giving the name, that's it. Okay, don't confuse here why it is RS1 like that, because these two are in series, these two are in series. Okay, if you take RS here, then RS here also. So that's why we should give a different name, right? So that's why here I have taken RS1. So 5 plus 10, that is 15 ohm. Okay, so now you can redraw this combination. See here, you can draw this combination like this. So RS1 is equals to 15 ohm. Now solve these two. So now I will take this combination as RS2. RS2, that is R3 plus R4. Okay, so this is 10, this is 5. So we'll get 15 ohm. Clear? Yes, 15 ohm. Next, you can redraw this circuit as, see, RS2 is equals to 15 ohm. Okay. Yes. Now these two are in parallel. Okay. So that is write 1 by R equal to 1 by RS1 plus 1 by RS2. So that is 1 divided by 15 plus 1 divided by 15. So 1 by R is equals to LCM is 15, and here you have to multiply. Sorry, only right 1 plus 1. So R is equals to 15 by 2. So what is the answer? 7.5. Okay. 7.5. So now once again you can redraw this circuit. You can redraw this circuit as so R is equals to 7.5. Okay, so total resistance of the circuit, that is R is equals to 7.5. Total resistance means you have to make, they will give 5, 3, 10, whatever resistance. Finally, you have to make those resistance into one resistance. Okay, so that is, then you get the total resistance of the circuit. So here total resistance of the circuit is R is equals to 7.5. Yes, now calculate current, total current in the circuit. So that is I, right? To calculate total current in circuit, we know the formula, that is V is equals to I into R. V is equals to I into R. Okay. We will calculate, bring all this and that is V by R equal to I. We can write V by R. So 12 divided by 7.5 into 10 divided by 10. So you will get 120 divided by 75. So what is the answer? Okay. So here you will get 1.6 ampere. So current I is equals to 1. Find I1, I2 and I in the given circuit. Given okay. Yes. Find I1, I2 and I in the given circuit. The given circuit. Yes, I is
I16, what is this? I is 1.6 ampere. Nipun Jain. So Nandini Paul answered I1 is 1 ampere. I1 is 1 ampere. Okay, then sorry, I1 is not 1 ampere. Wrong. I1 is not equal to 1 ampere.
See here, voltage across here and here, voltage is same. Why? Because across this resistor and this resistor, that is different. Why? Because these two are in series. Okay, but voltage across here and here, that is same. Okay. Yes, sir. See, if you want to calculate I1, first solve these two resistors. These two resistors are in series. Okay. First solve that one. Yes, sir. RS. So RS is equals to R1 plus R2. That is 5 plus 5 is equals to 10 ohm. Okay. Now you can redraw this circuit as 10 ohm. Here you can't take V1 equal to. Here you can't use this one directly. V1 equal to I1 into, sorry, V equal to I1 into R. Why? Because see, voltage here, voltage across here and here and here and here, that is same. But voltage across this resistance, this, that is different. Why? Because these two are in series. Okay, here voltage divides here and here. Okay, so that's why first to solve these two resistors. If we solve these two, it will become 1, right? It will become 1. Yes, now this is RS. RS is equals to 10 ohm. Okay, now calculate. Okay, now V is equals to I1 into RS. P is equals to I1 into RS. So V is 5. We read I1, right? Bring RS, that is V by RS equal to I1. I1 is equals to V by RS. So V is 5 volt. RS is 10. Okay. So 5 ones are 5 to that is 1 divided by 2. So I1 is equals to 0.5 ampere. I1 is equals to 0.5 ampere. So now you can calculate easily I2. Here only one resistor. So here directly you can use this formula. So V is equals to I2 into R3. V equal to I2 into R3. So here you are calculating current. I2 means what? Here I2 is current through this resistor. So what is the value of this resistor? That is 5 ohm. Okay, so that's why here you should use V equal to I2 into R3. Okay, next V is equal V divided by R3 is equals to I2. We can write I2 is equals to V by R3. That is V is 5 divided by R3 is 5. So here we will get current as 1 ampere. So I1 is 0.5 and I2 is 1 ampere. So now calculate I. Okay, to calculate I, see here, you this formula. I is equals to I1 plus I2. Why? Because now these two resistors are in parallel. So that's the reason why we can use I equal to I plus I2 this formula. Or instead of this one, you can use this formula also. V equal to I into R. Here you know the value of V, that is 5, but you don't know value of the R, right? But if you solve these two, then you will get the total resistance of the circuit. Clear? If you solve these two, then you'll get the total resistance of the circuit, and then you can use this formula. Okay, but if you want to use this formula, you have to do one more extra step. Means you have to calculate, you have to solve these two resistors. Instead of doing, just use this one, I equal to I1 plus I2. You will get the same answer. Yes, what is I1 value? 5. Okay, so now use this one. First calculate R value. So now these two are in series, right? So one by parallel, right? 1 by R equal to 1 by Rs plus 1 by R3. Okay, so 1 divided by 10 plus 1 divided by 5. So LCM is 1 by R is equals to LCM is 10. So 1 plus, and here 2, right? Okay, so 1 plus 2. So 10 divided by 3. What is the answer? Okay, so here R is equals to 10 divided by 33 ohm. Okay, now substitute here. So R is equals to 3.33. Yes, find the answer. So that is 5 divided by 3.3. So better here into 100 divided by 100. Okay, so you will get 500 divided by 33. So I is equals to 500 divided by 33. Yes, find the answer. What is the answer? Tell me quick. Yes, what is the answer? 1.5. Okay, so 500 divided by 33. So here we will get 1 point. Yes, 1.50. 1.50 ampere. We can write 1.5 ampere. See here we have used this formula and here we have used this formula, but the final answer is same. Okay. Current you can use either this one or this one. Okay, but if you use this one more extra step. Okay, so now time is very precious, sir, right? So that's why with this one. Okay, next one. Yes, here in the given circuit, calculate the total resistance of the circuit. Here one is resistor, another one is lamp. Okay, here they have given the resistance of the lamp, that is 18 ohm. Okay, calculate the total resistance flowing through the circuit, that is I. Okay, then potential difference across the lamp and resistor. Here the potential in the circuit, that is 6 volt. But now these two resistors are connected in series, so that's why potential difference it reduces, right? So calculate potential difference across the lamp and across the resistor. Okay, see here this question asked in 2008 Delhi competition exam. Okay. Yes, first find answer first. What is the total resistance? So now simple one. Both the resistors are in a series. That is RS is equals to. Sir, what is the difference between ammeter and galvanometer? Sampak Kumar. Okay. See, potential difference between ammeter which measures the current, and galvanometer which shows the existence of the electric field. Okay, it shows the electric current is like that. We will discuss more about the galvanometer in the next chapter. So we use that galvanometer which shows the existence of electric field or electric current, but ammeter which measures the electric current. Okay, got it, Mr. Sampat Kumar? Ammeter which measures the electric current in the circuit, and galvanometer which shows the electric current or existence of electric current. Yes, Nandini, R equal to 24 ohm, current is equals to 0.2 ohm. Yes, what is the total resistance? That is 18 plus 6, that is 24. Okay. Yes, then current I equal to V by R. Now see here, R is equals to, and take this as R1 and this as R2. So R1 plus R2, that is 18 plus 6 is equals to 24 ohm. So total resistance in the circuit, that is 24 ohm. So you can redraw this circuit as here. So R is equals to 24 ohm. Okay, you can redraw this circuit like that. Yes, next calculate the current. Huh? Current 4 ampere. Current. Wait, let's check. Okay, see here. So now we know the formula. So here V is equals to I into R. V by R is equals to I. I is equals to V by R. Substitute here. V is 6 divided by R is 24. 6 ones are 6, 4s are. So I is equals to 1 by 4, which means 1 by 4. Okay, 1 by 4 equal to 0.25. So current is 0.25 ampere. Okay, so total current in the circuit, that is 0.25. Now see here, current across this resistor, current through this lamp and current through this resistor, that is 0.25 only. Why? Because these two resistors are in series. So that's why current through lamp and through resistor is equals to 0.25. Okay. Yes. Now take voltage across lamp. I will take voltage across V1 and voltage across resistor R2 as V2. Okay. Yes. Find out. So V1 is equals to I into R1. We need V1. What is I value? That is 0.25. R1 is 18. So multiply 0.25 into 18. First, 0.25 into 18. Okay. So here we will get voltage across lamp, that is 4.5 volts. Okay, 4.5 volts. Next, find out V2. So V2 is equals to I into R2. V is 0.25 into 6. What is the answer? 1.1. 0.25 into 6. So here you will get V2 is equals to 1.5. So here V is sold. What is V1?